Hi, myself Yellappa. I am working as a assistant professor in St. Martin's Engineering College from ADS department. Today my topic is sorting. Sorting means heap sort in data structures. First, what is meant by sorting? Sorting means rearrange the elements in either ascending order or descending order. Whatever we are taking that elements, that we have to arrange either ascending order or descending order. In sorting, we have two types of sortings. First one is maximum heap and minimum heap. Maximum heap, we are storing the elements in first root node. We are taking maximum element and child nodes minimum elements. Always child nodes is greater than the root node. That is the maximum heap. Minimum heap means always we are taking the root node means small element and child node means greater than elements. Always we are comparing root node means compared to child elements. Here maximum heap example. For example, this is one array 19, 12, 16, 1, 4, 7. We are storing the elements. Here 19 maximum heap means 19 as a root node. Maximum element, that is maximum element 19 as a root node. And we are comparing always child nodes. Child nodes means minimum elements. Child nodes minimum elements. Suppose here maximum heap example 19 as a root node. Root node means maximum element. Maximum heap example always we are comparing root node means maximum element, that is 19. And child nodes always we are comparing root node means child nodes always less than the parent node. Suppose here 19 and 12 child nodes and 16 child nodes, and again comparing to root node 12 and 16 is child nodes, that is less than elements compared to root node. And again we have to compare 12. 12 means here root node, again 2 child nodes. Here 2 child nodes less than the parent node, because here maximum heap property means it satisfy the always we are satisfy the two conditions. First condition is root node is maximum element, and second condition is child node is minimum elements. So always we are comparing root node is less than the child nodes. So suppose 12 and 16 is less than the 19, and next 12 again we are taking 12 means, and 1 and 4 child nodes. 1 and 4 this child nodes is less than the parent node. Parent node is greater than. So and again 16 we are taking elements means here is 7 child node. Here 7 child node also smaller than the parent node. So this is one example. Next, minimum heap example. Minimum heap, in minimum heap example, first we are taking root node as a small element, and after that child nodes. Child nodes means greater than elements. Always we are comparing root node. Here always child nodes are greater than the parent node. Suppose here parent node 1 means that is the smallest element 1, and next here child nodes 4 and 16. 4 and 16 is greater than elements. Always we are comparing root node. Root node is child node. Root node is less than the parent nodes. So parent is greater than elements here. And again here taking 4 as a root node. Next 7 and 12. These 7 and 12 we are taking child nodes. These 7 and 12 is greater than nodes. Always we are comparing in minimum heap. We are comparing root node is a smaller than the parent nodes. Next 16, and again we are taking 16 as a root node. This is parent node, and child node 19. 19 is greater than element. So 16 is smaller than. Always we are comparing minimum heap means minimum element. Minimum element we are comparing. Here 19 means 19 is a greater than element. So always child node is greater than the parent node. Next, maximum heap. It is a binary. Maximum heap mainly uses binary tree concept. First we have to convert the array into binary tree, and after that we uses minimum heap and maximum heap. Based on the condition we have to sort the elements either in sorted order, unsorted order. That is ascending order or descending. Ascending means increasing order, descending means decreasing order. Here another example is, suppose we are taking some elements 16, 14, 10, 8, 7, 9, 3, 2, 4, 1. Suppose for example I am storing these elements. Heap first root nodes. Root node we are taking array of 1. Array of 1 we are taking elements. Next after that child nodes we are taking array of I index we are taking. After that a equal to 2 into I we are taking. Suppose whatever we are taking the elements root node we are taking I index. After that child nodes. Suppose maximum heap means larger elements. Large elements we are taking as a root node. After that child elements compared to root node, child elements is less than the parent node. So again 16 here, 14 and 10. 14 and 10 is less than the parent node. Next again 14 have a again 8 and 7. 8 and 7 also 14 is a greater than elements. This is the maximum is property condition. Next 8 and 7 less than the parent node. So 8 and 7 again, and again if you take 8 as a root node, next these child nodes 2 and 4. 2 and 4 also we are taking child smaller than the parent node. Next 7 again 7 having the one child. This is 1. 1 means child node. This is smallest element. So in mathematical property condition, always we are comparing root node. Root node must and should be greater than element, and child node must and should be less than the parent node. So again one is also small node. So this property is satisfies. Next again we are taking 10 as a root node means this is 9 and 3. 9 and 3 is child node. These child nodes are always less than the parent node. So you see here parent node is 10, and again 9 and 3 is child nodes is less than. So it's also satisfy the maximum heap property. Next here for example I'm storing normal I equal to 5 and I equal to 4 and index we are taking 3, 4, 5. Suppose for example here 16 is there in maximum heap condition. Suppose that property is not satisfied, the property is violated means we are swapping the elements. We are swapping the elements. Suppose here 16 means again we are swapping the elements. Next and again we are taking as a root node. Next here also 2 and 3, 4, 1, 4 like this based on the index value I equal to I plus 2 and right side also I equal to I plus 1 like this we are swapping the elements in maximum heap condition. In maximum heap for example is there. Suppose here again 16, 4, 10, 14, 7, 9, 3, 2, 8, 1 like this. We are taking some example here and we are taking array. Next here we uses all these elements using maximum heap property condition. Always we are comparing root node as a maximum element, and after that I index based on the I index iteration we are comparing the elements. Root node means greater than elements. Left node means I equal to I plus 1. Right side means I equal to I plus 2. Like this we are comparing the elements. Next here heap for example. Suppose here 14 is greater than elements, 4 is less than elements. Suppose here property is violates. Why? Because heap for example is maximum heap means always root node is greater than the chain nodes. So for that here we are swapping the element 14 as 4 plus 14. Like this we are swapping the elements. Next, here we are dividing the elements like 16 as a root node now. 16 as a root node, and heap for example, these all the conditions satisfies. These all the conditions satisfy because always root node is a maximum element. We are considered as a maximum element, and the chain nodes minimum elements. So always we are comparing root node here 16, 14, and again 10. Here two chain nodes, and again 14 have two chain nodes. 14 if we take as a root node 14 is a greater than element, and 8 and 7 is less than the parent node. And again 8 if we take 2 and 4. 2 and 4 is the child nodes. This is the smallest element compared to parent node. This is the less than the element. So this condition also satisfies for maximum condition. Next 7 and 1 as child node. 1 is smallest element and parent node is 7. 7 is greater than the parent. So the child node. So this condition also satisfied. Next 10 and 9 and 3. These child nodes 9 and 3. This is the smallest element, and here greater than the child nodes means maximum condition, property condition is satisfies. Here first sorting strategy is whatever we are taking elements, that elements is unsorted order. We have to arrange either ascending order or descending order. Ascending order means increasing order. Descending order means decreasing order. For example 10, 20, 92, 11, 15 and 80. These are the unsorted elements. Suppose I want to increasing order. Ascending order means this is the first 10, 11, 15 and 20 and 80 and 92. Like this, we are arranging ascending order. We are arranging ascending order elements 10, 11, 15, 20, 80 and 92. This is a ascending order. Suppose decreasing order means increasing order means arranging elements in whatever the elements minimum to maximum. Decreasing order means maximum to minimum. Maximum to minimum. Suppose here elements 92, 80, 20, 15, 11 and 10. This is the decreasing order. This is the maximum to minimum order. Maximum to, we are arranging the elements in maximum to minimum means that is the decreasing order. We are arranging the elements in minimum to maximum, that is the increasing order. This is the decreasing order. This is the increasing order. This is the increasing order. Suppose, for example, I am arranging elements in maximum heap. Maximum heap, I am arranging elements in maximum heap. Suppose, for example, 80, 20, 52, 60 and 90 and 10. Suppose maximum heap. Example, maximum heap. We have to construct the binary tree using maximum heap. For example, I want to construct this. First we are taking elements here 80 and 20 and 52 and again 60, 90 and suppose here 10. Like this we have to construct a binary tree using binary tree. Now maximum heap condition we have to construct a maximum heap. How we are constructing maximum heap means, suppose first in maximum heap means first maximum element we have to take as a maximum element as a root node. Maximum element as a root node. Suppose here 80 is there and here 90 is there. Maximum element means 90. So these 90 elements we can take it as a root node. So 90 means root node. So this condition is violation property of maximum heap. Why? Because this 90 is a child node. This is the 8 node as a normal root node. Suppose this 90 will be root node. We have to swap them as a root node 90. Now what we can do? Now again we have to swap. Suppose here 80 in 20 place 90 will be there. And same 52 and again 60 and again 90 plus 20, now 20 and here 10. So now 90 is there here and again we have to swap 90. Why? Because it is a maximum heap property means always root node we are considered as a maximum element. Now again we have to swap into 90 instead of place 80 place. So again we have to swap them. So now we are constructing root node as a 90. Now 90 we are constructing instead of here 60, here 80 is there. And 52 and 60 here and 80, 90 here 20 and again here 10. Now again we have to check. Now root node is maximum heap property condition satisfied. Why? Because here maximum heap is always maximum element. Here this order maximum element means 90. Maximum element means 90. That's why we are taken as a root node as maximum element. So these conditions satisfy. Maximum property condition is satisfies. Now again we have to check child node. Always child node is less than elements. Why? Because in maximum heap always parent node is a greater elements and chain load is a less than the parent node. So here 80 52 and 60 20 10. Now again we have to swapping the elements. Why? Because always we are comparing parent node and chain nodes. Parent node means greater than elements, chain node means less than elements. Now 90 is there and 80 52 is there. Okay, this condition satisfied. Why? Because here 60 is there. Here 60 is there. 60 means here 52 is there. This condition is not satisfied. Why? Because here elements is root node is greater than the parent node. Here child node is greater than and here root node is less than. This condition is violated. This condition is violated. Why? Because violated means here property, maximum properties, always we are comparing elements root node as a maximum element. Now again we have to swap this element. Again we have to swap this element. Now 90 and 80. Here 52 suppose here 60 here 60 we are writing here. Suppose and next here 80 we can add right side chain node. Next here 20 and 52 and 10. Now again we have to compare. Again we have to compare elements. Suppose 90 is greater than elements compared to chain node 60 and 80. 60 and 80 chain node is less than the parent node. So this condition is satisfied. Again we have to compare 60 chain node is 20. These condition also satisfied. So these two conditions satisfied. So next again 80 as a root node. Compared to 80 root node, here 52 is less than the element and 10 is less than the parent node. So these elements also satisfy the condition. These elements also satisfy the condition. So totally now maximum heap property condition satisfied. Why? Because the maximum heap means always we are taking as a root node as a maximum element and chain node. Whatever we are taking chain node, the chain nodes we are arranging as a compared to root node, arranging elements in smaller elements. So always we are comparing root node greater than elements compared to chain nodes greater than element. So this condition is satisfied. This is the maximum heap example. Maximum heap example. Maximum property condition satisfied. Next minimum heap. Minimum heap. Suppose minimum heap. I want to construct a binary tree using some elements. Minimum heap means example. Suppose unsorted elements. Suppose 90. 50, 80, 20, 35 and 10. This is unsorted array elements. Using minimum heap, we have to construct a binary tree. Now, I have to construct a binary tree 90 and chain nodes. I am taking 50 and 80 and 20. Next 35. Next here 10. Like this we are constructing a table using minimum heap. Now I want to construct a minimum heap. Using minimum heap property condition is always we are taking root node as a smallest element. Always we are taking as a root node as smallest element and chain nodes greater than the parent node. So always chain nodes we are taking as a greatest elements. Suppose here 90 is there. Here 90 is there and chain nodes 50 80 is there. So in minimum heap this condition is violated. This condition is violated. Why? Because in minimum heap, first we are taking elements root node as a smallest element. So this condition is violated means again we have to swap. Now again I am swapping 82 instead of 90. We are swapping 80. Now 80 and 90 here and the same 50 and 20 and 35 and 10. So again we have to check. Now root node is 80 and 50 and 90. Again here minimum heap means again this property is violated. Why? Because always we are comparing root node is minimum element. So 50 is minimum element here, child node, and 80 is greater element. So again we have to swap. So now 50 and here 80 and here 90 chain nodes. Next 20 and 35 and 10. Now again we have to compare root node and chain nodes. Now 50 is there, 80 is there, 90 is there, and 20, 35 and 10. Now minimum element we have taken as a root node. Now here 20 is minimum element and here 10 also minimum element. Now first I will construct a tree using minimum element. Now again I have to swap. Why? Because here minimum heap property condition is violated. Why? Because root node is a smallest element. You have to take root node as a smallest element. That is the property of minimum heap condition. Now here 50 element is there. So now again we have to swap elements. See like this. 2 times we have to swap. Now I will again swapping elements after that. 10, 80 and 90 and again 20 and 35. So now minimum element condition is satisfied. Minimum element condition is satisfied. That is the minimum heap condition. Why? Because minimum heap property is always we are comparing root node is a smallest element. Now chain node is greater than elements. So always the chain node is greater than the parent node. Chain node is greater than the parent node. Parent node is smaller than the chain node. So now again I have to swap. Why? Because the chain node is greater than the parent node. Why? Because the chain nodes are greater than the parent node. That's why again we have to swap. Here 80 and 10. 80 and 10. 80 and 10 is there, and here 20 is there and 35 is there. Suppose here root node is 80. Here 20 is there. Root node is always we are comparing in minimum heap. Always we are comparing root node is smaller than the chain node. So again we have to solve 20 here. 10 and 20 and here 80 and here 35 and here 90. So now again we have to swap. Here root node is 10. 10 means root node is smallest element. Minimum heap means the root node we are taking as a smallest element, and after that we are taking chain node. Chain node is greater than element. Now this condition is satisfied. Minimum heap property condition is satisfied. Why? Because the chain node is 20 and 90 and 10 is minimum element. 10 is we are considered as a minimum element means this condition is satisfied. And again we have to compare 20. If we take 20 as a root node is a minimum element. That is this condition also is satisfied. And again we have to take smallest chain nodes. Chain nodes we are comparing. Always we are comparing chain nodes means this chain node is greater than the parent node. So this chain node is greatest element 80. This condition also satisfied. And 35. And again we have to construct binary tree means 35 means this chain node is also smallest element compared to root node. Root node is greater than element. So this condition also satisfied. Next 10 after that we are taking chain node as a 90. These condition also satisfied. So always we are comparing root node as a minimum element and chain node is maximum element. So we are comparing elements in minimum heap means whatever we are taking elements, that elements using minimum heap. First we have to take root node as a minimum element, and after that we have to take chain nodes. Always we are comparing greater than the parent node. So this is the minimum heap example. This is the minimum heap example. Suppose based on the I iteration using minimum heap and maximum heap condition, first we are converting to the binary tree using array, and after that we have to sort the elements in either ascending order or descending order. Here we are taking left and right childs. Here I into I plus 1 left childs and I into I plus 2, like that we are taking right side elements, and root node we are taking always in maximum heap greater than the chain nodes, and minimum heap always we are taking the less than the parent node. Here some conditions based on the minimum heap and maximum heap. We are using this iteration. Based on iteration, we have to construct a binary tree using binary tree, minimum heap and maximum heap. This is, suppose if you take 12, 16, 19. This is minimum heap condition. Suppose minimum heap means parent node, always we are taking parent node as a minimum element, and child node is 16 and 19. This is the one condition. This satisfies minimum heap condition. Suppose here also 19 and 16. Here this property is violated. Why? Because minimum heap always we are taking elements in minimum heap. Root node we consider as a minimum element. Here 16 is minimum element and 19 is larger than the parent node. So that's why here we have to swap. See like this. We have to swap minimum and maximum elements. Next, here one example 1, 4, 7, 12, 16, 19 using one array. Now in minimum heap, always we are taking elements as a minimum element and maximum heap we are taking as a maximum element. Suppose here one will take, one we are consider as a root node means minimum element 1. Then now we are taking as a child node 4 and 7. 4 and 7 is greater than the parent node. Now 4. If you take 4 as a root node, parent node, 12 and 16. 12 and 16. 12 and 16 is greater than elements. Compared to parent node, always minimum be greater than the parent node. And here 7 also. 7, if you take 7 as a parent node, 7 is smaller elements, and 19 is greater element. Always in minimum heap we are using as a minimum element as a root node, and child node is a greatest elements. This is the maximum heap example. For example, 19, 12, 16, 1, 4, 7. Here always we are taking elements in maximum heap. We are constructing a binary tree, using array, we are converting, and after that minimum maximum. Suppose if you take root node as a 19, this is maximum heap example. For example, 19 as a root node, and we are taking as a child nodes 12, 16. This is the smallest element compared to root node. Always we are comparing root node as a greatest element and child node as a smallest element. And next, if you take 12 as a root node, 1 and 4 is a smaller than the parent node. And here 16 will take 7 is the smaller than the parent node. So maximum heap property condition satisfied. Suppose like this, we have to insert the elements. We have to insert the elements in maximum heap means child nodes minimum elements and parent node maximum elements. Now I will show one video. Heap start using heap start video. Suppose here heap start, we are taking some indexes array using array. Heap start means it is a comparison based technique. It is one of the most processing data technique. We uses either ascending order or descending order. In first we have to take elements in either ascending order or descending order. Heap start here. First whatever we are taking the elements, we are converting the using binary tree and array, and after that based on the iteration, we are taking I index as a root node, and after that left child means I into I plus 1 and the right side means I into I plus 2. Like this, we are taking elements. Suppose here 2, 10, 4, 7, 1, 8, 9, 3, 6, 5. These are the unsorted array elements. These are the unsorted elements. Using this, we have to construct a binary using minimum heap and maximum heap. Next, suppose here we have to arrange the elements in 2, 10, 4. Normally, whatever we are taking the elements, first we have to construct root node and child node. Just 2, 10, 4 and 7, 1 and 8, 9 and 3, 6, 5. Like this, just we have to construct a binary tree. Heap 5 the binary tree. Now, again we have to construct a binary tree. Using heap 5 method, we are taking root node as I index, and after that left side means I into I plus 1, right side means I into I plus 2. Like this, here we have to construct a binary tree. Using binary tree. Next, here elements. Maximum heap means always we are taking elements as a maximum heap. So again we have to, if any condition is not satisfied, that's condition violated means we have to swap the elements. We have to swap the elements as a root node. And after that we have to see here 4 and 7 swap. Next. Like this I iteration, based on the I iteration index value, we have to swap the elements. And after that we have to arrange the elements. We have to arrange the elements in ascending order means increasing order, descending order means decreasing order. Minimum to maximum elements. We are arranging elements minimum to maximum means that is minimum heap. We are arranging elements maximum to minimum means that is maximum heap. That is maximum heap condition. We are decreasing order. That is decreasing order. Always we are taking maximum heap means we are taking element as a greater element and child nodes is a minimum element. And minimum heap we are taking as a minimum element, and smallest element we are taking as a root node, and greatest elements we are taking as a child node. So this is the minimum heap and maximum heap conditions.
Wait, sir. It will come. Shall come. Sir, only 1 minute, sir.
So swapping the elements means first in swapping the elements means using array, we are converting using array binary tree, and after that we have to swap minimum element and maximum elements. Minimum heap, maximum heap. Like this sorting methods, we have to use heap sort. In these two types, based on the two types, minimum heap, maximum heap, we have to construct a binary tree. Using minimum heap means first we have to take elements root node as a smallest element and chain node as a greatest element. And maximum heap means we have to construct a binary tree. First maximum heap means first we have to take greatest elements and after that chain node is a smallest element. If any condition is violated, that time we have to swap the elements. So today we discuss minimum heap and maximum heap in data structures. Thank you all.